New wonder drug for weight loss allows you to eat as much as you want of any food. The obesity epidemic has been a growing concern worldwide. With over 1 billion individuals affected, scientists have been fervently searching for new ways to combat this health issue, developing ways to people with weight loss. An exciting discovery was published today from the Center for Cognition and Sociality, CCS, within the Institute for Basic Science, IBS. Under the leadership of Director C. Justin Lee, the research team has uncovered fascinating details about how our brain influences our body's ability to burn fat. At the heart of their study are the intriguing, star-shaped non-neuronal cells in the brain known as astrocytes. While most research in obesity and brain function has primarily centered around neurons, this study highlights the critical role that astrocytes play in regulating fat metabolism, managing weight loss and energy. Traditionally, the hypothalamus in the brain has been identified as the central hub managing the delicate balance between food consumption and energy expenditure. The neurons in the lateral hypothalamus have always intrigued scientists due to their connections to fat tissue. But their exact role in the puzzle of fat metabolism regulation remained elusive. New wonder drug for weight loss allows you to eat as much as you want of any food. Move over pythons. These snakes are the true eating champions. Humans almost went extinct as population declined to only 1,280 people. 1 billion deaths over the next century from climate change. Study. Coastal wetlands are inching closer to extinction as the world heats up. Read more. The jigsaw started coming together when the research team found a unique cluster of neurons in the hypothalamus, distinctively expressing the receptor for the inhibitory neurotransmitter GABA, gamma-aminobutyric acid. The cluster is associated with the alpha-5 subunit of the GABA receptor and was fittingly termed the GABRA5 cluster. How the study was conducted. When studying diet-induced obese mice, the researchers identified a marked slowing down in the pacemaker firing of these GABRA5 neurons. An attempt to curtail the activity of these neurons led to reduced energy consumption, causing weight gain. Conversely, stimulating these neurons allowed the mice to shed weight, pointing to the GABRA5 neuron's potential role as a weight-regulating switch. However, the plot thickened when the researchers discovered the unexpected culprits behind the scene, the astrocytes in the lateral hypothalamus. These astrocytes were found to directly influence the activity of the GABRA5 neurons. Reactive astrocytes, in particular, became more numerous and enlarged, excessively producing the MAOB enzyme, monoamine oxidase B. This enzyme, vital for neurotransmitter metabolism in the nervous system, culminated in producing a significant amount of GABA, which in turn stifled the activity of the surrounding GABRA5 neurons. The silver lining was realized when it was found that curbing the MAOB gene's expression in these astrocytes could decrease GABA secretion. The consequent outcome was increased energy consumption and weight loss in heavier mice. This occurred even while they indulged in a high-calorie diet. This discovery underlines the potential of targeting the MAOB enzyme in astrocytes as a revolutionary treatment for obesity without affecting one's appetite. New weight loss wonder drug. In line with this discovery, a potential wonder drug named KDS-2010 has been developed. This drug, a selective and reversible MAOB inhibitor, had been previously transferred to the biotech company Neurobiogen in 2019 and is now undergoing Phase 1 clinical trials. In tests on obese mice, KDS-2010 showcased remarkable results, significantly reducing weight without affecting food intake. Postdoctoral researcher S.A. Moonson expressed, previous obesity treatments targeting the hypothalamus mainly focused on neuronal mechanisms related to appetite regulation. She emphasized the novelty of their approach, stating, "To overcome this, we focused on the non-neuronal astrocytes and identified that reactive astrocytes are the cause of obesity." Echoing this sentiment, Center Director C. Justin Lee expressed optimism for the future, noting, "Given that obesity has been designated by the World Health Organization, WHO, as the 21st century emerging infectious disease, we look to KDS-2010 as a potential next-generation obesity treatment that can effectively combat obesity without suppressing appetite." This study opens a new frontier in our understanding of obesity and the potential avenues for its treatment. The emphasis on astrocytes challenges traditional approaches and offers hope to countless individuals worldwide battling this condition. The journey to understanding the intricate dance between the brain and body continues. It's discoveries like these that pave the way forward. More about the obesity epidemic. The obesity epidemic refers to the alarming and substantial increase in the number of individuals who are obese over the past few decades. This surge in obesity rates is not limited to just one country or region. It is a global issue, affecting both developed and developing nations. Key aspects of the obesity epidemic. Prevalence. According to the World Health Organization, WHO, worldwide obesity has nearly tripled since 1975. As of recent data, almost 1 billion adults are obese. Childhood obesity. The epidemic is not limited to adults. There's a significant and growing number of children and adolescents who are overweight or obese. This early onset of obesity can lead to health complications in youth and a higher risk of adult obesity. Health implications. Obesity is linked to numerous health issues, including heart disease, type 2 diabetes, certain cancers, and even respiratory and musculoskeletal disorders. Furthermore, it can reduce overall life expectancy. Economic impact. Beyond the health implications, the obesity epidemic also has vast economic repercussions. Treating obesity-related diseases places a significant financial strain on healthcare systems. Furthermore, it can result in decreased productivity and increased absenteeism in the workforce. Causes. The epidemic stems from a combination of factors. Dietary changes. There's been a notable shift towards increased intake of energy-dense foods that are high in fat and sugars but low in vitamins, minerals, and other essential micronutrients. Physical inactivity. Sedentary lifestyles, often due to changing modes of transportation and increasing urbanization, contribute to the problem. Genetics. While lifestyle factors are crucial, genetics can make certain individuals more susceptible to gaining weight. Societal and environmental factors, lack of access to healthy foods, absence of safe places to exercise, and certain cultural norms can promote obesity. Response. Many governments and organizations worldwide recognize the severity of the obesity epidemic and are implementing policies, programs, and initiatives to combat it. These range from public health campaigns and education about nutrition to the regulation of food advertising and the creation of more pedestrian-friendly urban environments. In essence, the obesity epidemic is a complex, multifaceted issue that poses significant health risks to individuals and challenges to societies at large. Addressing it requires a combination of personal, societal, and policy-driven approaches. More about the science of weight loss. Weight loss is a complex physiological process influenced by multiple factors. These include nutrition, exercise, genetics, hormones, and lifestyle. Let's delve into the science behind weight loss. Caloric balance. At the core of weight loss is the principle of energy balance. If you consume fewer calories than your body expends, caloric deficit, you'll lose weight. Conversely, consuming more calories than you burn, caloric surplus, will result in weight gain. Basal metabolic rate, BMR. This is the number of calories your body needs to maintain basic physiological functions like breathing, cell production, and nutrient processing when at rest. BMR accounts for about 60 to 75% of daily calorie expenditure. Thermic effect of food, TEF. Digestion, absorption, and storage of food require energy. Typically, the TEF accounts for about 10% of your daily caloric expenditure. Physical activity. Calories burned through physical activities can vary widely depending on the intensity, frequency, and type of exercise. Physical activity can include anything from walking to intense interval training. Fat storage and breakdown. Your body stores excess energy in fat cells. During times of caloric deficit, the body releases enzymes that break down fat stored in cells. This process releases energy in the form of fatty acids. These fatty acids then enter the bloodstream to be used as fuel, especially during prolonged physical activity. Hormonal regulation. Several hormones play crucial roles in weight management. Insulin facilitates the uptake of glucose into cells. High insulin levels promote fat storage. Ghrelin, known as the hunger hormone, it signals the brain to initiate food intake. Leptin, produced by fat cells, it signals satiety and suppresses hunger. Cortisol, a stress hormone, when chronically elevated, can lead to increased appetite and fat storage, especially in the abdominal region. Adaptive thermogenesis. When you cut calories, your body may reduce the number of calories it burns in response, making weight loss more challenging over time. This is a survival mechanism from our evolutionary past when food scarcity was common. Muscle versus fat. Muscle tissue requires more energy to maintain than fat tissue. As you build muscle through strength training, your resting metabolic rate, the rate at which you burn calories at rest, can increase, aiding weight loss. Macronutrient balance. Different macronutrients, proteins, fats, carbohydrates, have varied effects on satiety, metabolic rate, and hormones. For instance, protein has a higher TEF and can make you feel fuller longer, aiding in weight loss. Genetics and microbiome. Genetic factors can influence how your body stores fat and how it responds to diet and exercise. Additionally, the gut microbiome, or the collection of microbes living in our digestive tracts, might also play a role in weight management. Lifestyle factors. Sleep, stress, and other lifestyle factors can influence weight. For example, lack of sleep can disrupt hormonal balance, leading to increased hunger and weight gain. In summary, while the principle of weight loss, burning more calories than you consume, sounds simple, the physiological and psychological processes governing it are intricate. A combination of dietary modifications, exercise, and lifestyle changes is often the most effective approach.
វីដេអូនេះឧបត្ថម្ភដោយ Matkim KH ជា page បង្រៀន free និងលក់សៀវភៅងាយស្រួលរៀនដ៏សម្បូរបែបគ្រប់កម្រិតថ្នាក់សូមអរគុណ